Shocking James Webb Telescope discovery about quasars, Kuiper belt. The James Webb Space Telescope by NASA will be used to study the black hole of quasars, the bright objects that are capable of emitting energy that is highly powerful than the other stars in the galaxy. In today's video, we are showing you the shocking discovery about the Kuiper belt. Hello everyone, welcome back to the Tech Universe. Before starting, don't forget to hit the like button and subscribe to our channel to get more updates on the space and tech world. That being said, let's begin. So it all started with the tennis court-sized infrared observatory that was launched on Christmas 2021 from French Guiana, and finally arrived at the destination Lagrange point between the Sun and the Earth on 24th January 2022. During the entire decade or more within the orbit, James Webb was used by the astronomers to discover various celestial phenomena that include the black holes and exoplanets. Among the first targets will be the quasars, which are the bright objects powered by black holes and range from millions of sun masses to billions of them. What are quasars? Well, it is a short form of quasi-stellar radio sources that are known as the active galactic nucleus, discovered in the heart of galaxies alongside supermassive black holes. They are used to emit energies in the electron volt and exceed the estimated output of all stars in the galaxy. They are around 3,260 light-years across, and the regions emit huge amounts of electromagnetic radiation within the jets and can be so much brighter than the sun. But the ironic thing is, they last only 10 to 100 million years and hence are tough to spot in galaxies that are so old. The rapidly spinning disk also spews jets of particles moving outward, and these energetic engines are brighter emitters of radio and light waves. The farther the light will travel, the more it will redshift, and the light from the early universe gets stretched as it is shifted to the infrared whenever it gets to Earth. This is the frequency noted by the James Webb Telescope during the observation. The team of quasars studied is not only among the most distant in the multiverse, but also among the smartest. With the highest black hole general public and accretion rates, the rate at which substance falls into the black hole itself. The brighter the quasar, the stronger the absorption line features in the spectrum line will be. By determining whether the gas is neutral or ionized, scientists will learn how impartial the universe is and how much of the reionization process has occurred at that point in time. You need very bright backstory sources if you ever want to study the universe. A quasar is an ideal object in the distant universe because it is bright enough for us to see it clearly, said team member Camilla Pacifici. Pacifici works as an instrument scientist at the Space Telescope Science Institute in Baltimore, but is affiliated with the Canadian Space Agency. We desire to study the previous universe because the universe will evolve, and we want to know how it began, the researcher added. So they will scan the light from quasars for metals, which are any elements heavier than hydrogen and helium that formed in the first stars and galaxies. Scientists also studied quasars with James Webb, examining the properties and hosting of galaxies and how they are interconnected during the initial stages of evolution in the universe. The astronomers will also be using quasars to determine the gases in the space between some galaxies from the period of cosmic reionization that faced an end during the young age of the universe. It is also able to do the entire thing resulting from the light from distant objects that took billions of years to reach the telescope. So it is like seeing the light as it was emitted near the dawn of everything one should know. All the quasars astronomers were studying existed earlier, when the universe was around 800 million or so years old, or less than 6% of its age now. So the observations allow us to study the supermassive black hole formation, galaxy evolution, and more at early times. In addition, light from these ancient objects was stretched by the expansion of space that is known as the cosmological redshift. Surprisingly, quasars, which are high-energy objects, are powered by black holes. So yeah, all galaxies incorporate a supermassive black hole when the dust or gas inflows to this hole and reaches a certain level. The event will cause a quasar to form, the bright region, as the material will swirl around the black hole. In the first round of scientific observations, astronomers using James Webb will examine some part quasars will play in the galaxy evolution during the early times. This will give them a deep insight into how the early universe was formed, comprising a representation of the gas within the space between the galaxies billions of years earlier. James Webb was able to peer deeper into the history of the universe than any space telescope due to its position a million miles from the Earth. In addition, it has a higher resolution infrared instrument on board that makes it extremely sensitive with low levels of light, perfect to study the gas around quasars. We're interested in investigating the most luminous quasars because the very high total energy that they generate down at their cores should have the greatest impact on the host galaxy through mechanisms like quasar outflow and heating, said Chris Willett. He is a postdoctoral researcher at the National Research Council of Canada's NRC Herzberg Astronomy and Astrophysics Research Centre in Victoria, British Columbia, and the Canadian Space Agency's CSA, Webb project scientist. Webb is a collaborative effort between NASA, the European Space Agency, and the Canadian Space Agency. They desire to observe these quasars when they have the greatest impact on their host galaxies. An immense amount of energy is released as the matter is assimilated by the supermassive black hole, which warms and pushes the surrounding gas outwards. This causes strong outflows to rip across interstellar like a giant tsunami, wreaking havoc on its host galaxy. These outflows, according to experts, are critical in the evolution of galaxies. Star formation decreases as the gas in the dismissals is removed from the galaxy. Outflows can be so powerful and expel so much gas in some cases that they can completely halt planet formation within the host galaxy. But according to scientists, they are the primary mechanism by which gas, dust, and aspects are redistributed over great distances within the galaxy, or can even be expelled into the intergalactic medium, the space between galaxies. This could cause fundamental changes in the properties of both the host galaxy and the intergalactic medium, which the team hopes to investigate. They would like to go back 13 billion years, whenever the universe was only a billion years old, and examine the neutral gas between galaxies, which caused it to appear opaque. Over hundreds of millions of years, this neutral gas became ionized, making it transparent to ultraviolet light, a period known as the era of reionization. Talking about the instruments on the telescope of James Webb, firstly, it has an IR cam. It is the near-infrared camera, an infrared image viewer from the visible to the near-infrared NIR spec, near-infrared spectrograph, that will also perform spectroscopy over that wavelength range. MIRI, mid-infrared instruments, will quantify wavelengths ranging from 5 to 27 micrometers in the mid to long infrared range. The FGS NIR ISS fine guidance sensor near-infrared imager and slitless spectrograph is used to stabilize the observatory's line of sight during science observations. What caused this period is unknown, but astronomers hope Webb will be able to answer this question. The squad will be able to have a better view of the gas that gets to sit between the Earth and the quasar by using the quasars as a backstory light source. The quasar's light is absorbed in specific wavelengths by that gas, and the team can look for spectral lines in the gas to learn more about the ionization process. These metals would have been ejected in the huge outflows and should be visible in the wide-ranging gas between the quasar and the Earth. The team intends to measure the generation of these first metals, as well as the manner in which they are pushed out into the interstellar medium by these early outflows. So this is all about the shocking James Webb Telescope discovery for Kuiper Belt's quasars. What do you think about the discovery? Do let us know your views and opinions in the comment section below. Stay tuned and subscribe to our channel for more uploads like this. We'll see you in the next one. Until then, peace.